In this tutorial, we're going to learn how to generate state point analysis charts. State point analysis is a useful tool applied by engineers to gain insight into the current or anticipated operating regime of a secondary settling tank with respect to whether the settling tank is safely, critically, or overloaded. With a few mouse clicks, BioWin can generate a state point analysis chart for a given set of sludge settleability characteristics. BioWin takes state point analysis charts beyond the traditional desktop analysis typically performed by engineers because it's able to illustrate the changes of the secondary settling tank operating regime under dynamic loading conditions. For example, the square red points in the sample chart shown show the different state point locations over a 2.5-day simulation under varying flow and load to the plant. The gravity flux is traditionally drawn using Vesselin model settling parameters. In BioWin, the gravity flux is drawn by default using the modified Vesselin model. The parameter values used are shown below the state point chart in red text. If the settling parameters are changed, the gravity flux curve will be updated on the fly. Because the chart itself does not know the unit system, for example, whether we're using SI units or US imperial units, the label that BioWin initially applies to the vertical flux axis shows units for both systems. The user can then edit out the unit system that does not apply. I will show steps to do this a little later on in the tutorial. The unit label on the vertical axes does not impact the actual values plotted in the chart. These plotted values will be in the correct units specified for the model. To add a settling tank state point analysis chart, right-click on the secondary settling tank element and select Add to Album from the resulting pop-up menu. Next, select Chart from the resulting flyout. If you are presented with the choice of adding the series to an existing chart, click Yes or No. If you select No, the chart will be added to a new page in the album. I'm going to choose No. The Plot Selected Parameters dialog box will now open. Select the State Point tab. Check the boxes for the various lines you want to show on the state point chart. By default, all are checked except the Plot Dynamic State Point History option. You can select the Plot Dynamic State Point History option if you want to see those square red points that track the movement of the state point during dynamic simulations under varying flow, load, and recycle for the secondary settling tank. This is a very useful feature to add to your chart. If you want to place a limit on the number of historical state points that are drawn, enter the value in the max number dynamic points box. Leaving this setting at the default 0 means that there is no limit on the number of points drawn. I'm going to leave this as a 0 for now. Click the Plot Selected button to generate the plot in the album, and then click Close. When we open the album, the new page with our state point analysis chart should be visible. We can edit the chart to improve the presentation. Our current project is based in SI units, so we can edit the left axis title to reflect this. Right-click on the chart and select Edit Axes from the pop-up menu. The left axis is selected by default. Click on the Title tab and remove the US units from the title. Click Close. Let's run a dynamic simulation for 2 days. We can see how the dynamic loading changes our overflow and underflow series. Next, let's decrease the settleability of solids in the model clarifier unit to see how our state point analysis changes. You can change the model settling parameters by going to the Project menu and selecting Parameters and then Settling from the Flyout menu. I'm going to reduce the maximum Vesselin settling velocity to 80 and increase the Vesselin hindered zone settling parameter to 0.5. These are extremely poor settling characteristics. Now, if we reopen the album and select the Dynamic Simulation button, I'm going to run a dynamic simulation for 2 days from the project start date. We can see from our state point analysis that our clarifier becomes overloaded under these extremely poor settling characteristics. We can also look at the effluent total suspended solids concentration. The red line shows the effluent TSS under default settling parameters, while the blue line shows the effluent TSS under poor settleability conditions. We can see that the effluent TSS under poor settleability conditions is significantly higher than that under the default settling parameters. In this example, we've used a model clarifier element to generate our state point analysis chart. It is also possible to construct a state point chart for an ideal secondary settling tank. In this case, the Vesselin model parameters are used to construct the gravity flux curve, and the ideal secondary settling tank area, underflow, etc. are used in all the calculations. This approach is useful for alerting to possible critical or overloaded secondary settling tank conditions that the ideal settling tank would not normally indicate to the user directly without the additional complexity of a model secondary settling tank. This concludes the tutorial on generating state point analysis charts. For more information on special charting in BioWin, please see the special chart formatting playlist in EnviroSim's video library. Please also review our other video tutorials to help you become more productive with BioWin.